So we have model 24, differentiation applied to inverse functions. And the only inverse function whose differentiation we need to know in our syllabus is tan inverse. So first of all, let's start off with the basics. What's the differentiation of tan inverse of x? You need to remember that it's dy over dx plus dy over dx is equals to 1 over 1 plus x squared. But I also believe it's important for you to understand how we got to this result. So for this case, I'll give you the background. That is, let's just start off by rearranging this thing as x is equals to tan y. Now, if we are to differentiate x, since it's in terms of y, we will write this down as dx over dy. Dx over dy is equals to the differentiation of tan is sec square x. Sec square y. My bad. Then the next step is gonna be, since we need to find dy over dx, we will cross multiply. And we'll end up with dy over dx is equals to 1 over sec square y. We'll take this step by step. If we were to further simplify this, we can write down dy over dx as, just a second. So we do know that the identity that sec square x is equals to 1 plus tan square x, and that's exactly the identity we're gonna use. So we have 1 plus tan square x. Now tan square y, my bad, since this is y and this is also y. Be careful with this, guys. And finally, we can write this down as like this, and you know that tan y is equals to x. So simply write this down as 1 over 1 plus x square, and that is our final result. And this is exactly how we ended up with this. You must understand how you got to this result in order to avoid making mistakes. You must. Moving on, since you should also know the shortcut so as to solve such questions, let's solve these. So if we have something like this, first of all, the simple differential is that we're going to write this like this, and whatever is inside tan inverse is going to go to the denominator and plus 1 whole square. Alright, and we are going to multiply this whole fraction by the differential of whatever was inside tan inverse. And finally our answer is 1a over 1 plus ax whole square. Moving on, what if we have tan inverse of a general function? That is a generalized formula we are going to derive. So first of all, the simple thing, that's the simple differential of tan inverse of x, and fx goes down and we're going to square fx, and we're going to multiply this whole fraction by the differential of fx, as we did above. Whatever is inside tan inverse goes to the denominator and gets squared, and we multiply the whole fraction by the differential of the function. So this is our generalized formula. Moving on, a few more examples to wrap things up. So the differential of this thing is going to be, since you already have phi here being multiplied, this is not going anywhere. Alright, so 1 plus, or for now you can just take this out because it's not going to affect our calculation. So as we learned, 3x goes to the denominator and gets whole squared, and the fraction gets multiplied by 3. And our final answer is going to turn out to be 15 over 1 plus 9x squared. We need not apply product rule in this case since it's simply a numeric number. But since in this case we have a function, we must apply product rule. So x is my u and tan inverse of x is v. So the differential of x is 1. The differential of tan inverse of x is, as we learned, 1 over 1 plus x squared. Applying product rule, we have uv dash plus vu dash is equals to x into 1 over 1 plus x squared. I'm simply substituting the values, and tan inverse of x into 1, leaving our answer as this. So this is our answer, and this is where we happily wrap things up. So first of all, we learned the basics and the background why the differential of tan x is what it is, and we used these concepts to further build upon further examples and how we proceed when there's a function inside tan inverse. And yes, we did derive a generalized formula for this. So we wrap things up there. Thank you.